In 1967, a telescope in Cambridge picked up a signal that should not have existed. A pulse, then another. Every 1.337 seconds, precise to the fraction of a heartbeat, arriving from deep space with the regularity of a machine. Nothing in nature is that perfect. So for a few days, the scientists did something they almost never admit to. They wondered if someone was calling. They labeled the source LGM1, Little Green Men. It wasn't aliens. The truth was stranger and far more terrifying. That flawless ticking wasn't a message. It was the sound of a dead star, a corpse the size of a city, spinning so fast it should tear itself apart, firing a beam of radiation across the galaxy like a lighthouse of the dead. And it had been screaming that signal into the void for 1,000,000 years before it ever touched our antenna. This is a pulsar. And once you understand what it actually is, you will never look at the night sky as something peaceful again. Start with the corpse itself. A pulsar is a neutron star, the crushed heart of a star that died. When a giant star runs out of fuel, its core collapses in less than a second. Everything it ever was, a ball of fire wider than our sun, gets squeezed into a sphere just 20 kilometers across, the size of a city, but it still carries more mass than our entire sun. Let that break in your head. Take the sun, crush it down to the size of your hometown. That is the density we're talking about. A single teaspoon of this star weighs about 1 billion tons, more than every human being on Earth, combined, balanced on a spoon. Drop a marshmallow onto its surface, and the impact would release the energy of an atomic bomb. You could never stand on it. The gravity is roughly 2 billion times stronger than Earth's. If you fell toward it, you wouldn't land. You'd be stretched into a stream of atoms and flattened across the surface before you ever arrived. This isn't a place. It's a machine for destroying matter. But the density is not even the strangest thing. Because this city-sized corpse does not sit still, it spins. When the giant star collapsed, it kept its rotation, but crushed into a tiny ball, it spun up, the way a figure skater pulls in their arms and whips into a blur. The Crab Nebula pulsar turns 30 times every second. But that's slow. The fastest known pulsar, buried in a star cluster, spins 716 times per second. A ball heavier than the sun, wider than a city, turning 716 times in the time it takes you to say the word pulsar. Its surface is moving at nearly 1/4 of the speed of light. Physics says it should fly apart. It doesn't, because gravity that strong simply refuses to let go. And here is where it starts shooting. A pulsar has a magnetic field 1 trillion times stronger than Earth's. That field funnels radiation into 2 tight beams blasting out of its magnetic poles. As the star spins, those beams sweep around and around, and if one of them happens to point at Earth, we catch a flash. We aren't hearing a signal. We are standing in the path of a rotating cannon, catching the muzzle flash each time it swings past. That perfect pulse from 1967 was a beam of death, brushing across our planet hundreds of times a minute. But the dead have company. In 1992, astronomers found something orbiting a pulsar called PSRB 1257+12. Planets. The very first planets ever discovered outside our solar system did not orbit a warm, living star. They orbited a corpse, bathed in lethal radiation. sterile, silent worlds circling a lighthouse that would kill anything that ever tried to live there. Before we ever found a planet like Earth, we found a graveyard. And yet, for all this horror, the pulsar is also the most reliable object in the universe. Those ticks are so precise, they rival atomic clocks. So precise that we use them. When Voyager left the solar system, we bolted a map to its side. And the way that map marks our home is not by naming stars. It points to 14 pulsars, using their exact ticking rhythms as galactic coordinates. If anything ever finds Voyager, it will trace us home by following the dead. We use them for something even bigger. Spread across the galaxy, pulsars form a web of clocks. And in 2023, scientists watched those clocks all shiver by billionths of a second, in unison. What moved them was gravitational waves, ripples in space itself, rolling through the galaxy from colliding black holes. We detected the trembling of reality by watching the corpses of dead stars flinch. But nothing ticks forever. Every pulse costs energy. Slowly, over millions of years, a pulsar spins down. The flashes come slower, slower, until one day the beam goes dark and the lighthouse switches off for good. Right now, the galaxy is full of them we can no longer hear. Dead stars that finished counting, drifting in silence, invisible forever. That is the truth the 1967 signal was really telling us. It was never a greeting. It was a countdown. Every pulsar in the sky is a clock that is running out. A corpse spinning down towards silence, marking time it doesn't have. So the next time someone tells you the stars are peaceful, remember what's really out there. Cities of crushed matter, beams of radiation sweeping the dark, dead worlds orbiting dead suns, and thousands of ticking clocks scattered across the galaxy, each one quietly counting down to the moment it stops forever. We thought something was trying to reach us. Really, the universe was just showing us its clocks, and every single one of them is winding down.